Hi guys, since I'm not there today, I'm going to walk you through a few of the problems on worksheet 1B, being force diagrams with component forces, which we have done before with breaking up velocities into X and Y components when we did projectile motion last unit. So again, the first thing we do is read the problem and identify our object of focus. In this case, it's the water skier. So we circle the water skier and any objects that are touching or interacting with him or her are placing forces on him or her. So we definitely have gravity acting downward, and the rope is pulling to the right. So I forgot, force due to gravity going down, and any rope, chain, string is a tension force. And if you notice, the skis are at a slight angle. So we're not including the skiers because our force diagram is for the water skier. And the skis are pushing him slightly up to the left. So we're going to have a force going up in that direction, and we're going to call that normal force, since that is a surface. And if you notice, not all of our forces are going in the X or Y direction. So that means we're going to have to break them up so that we can eventually prove whether this object is accelerating or not. So if we imagine he or she is not accelerating, we're going to have to break up normal force into its X and Y components. So we're going to have force normal in the X direction, which would eventually be negative since it's to the left. And then we have force normal in the Y direction. So assuming the water skier is not accelerating and therefore moving at a constant velocity, all of our X direction forces would have to be equal, and all of our Y direction forces would have to be equal. So then again, if we try number 2, object of focus here is the system of the kids and the sled. So there they are. And we have force due to gravity going down. We're going to have a normal force caused by the ground or the snow going upward. And at an angle, we'll have a tension force caused by the rope. Now, assuming, again, they are moving at a constant velocity, there is some components going to the right, so we would have a force going to the left, and that would be due to friction between the snow and the sled. And if you notice, the only force not in the X or Y is tension, so we'll have to break that up into its X and Y components. So we have force of tension in the X, and then force of tension, it's a little hard to fit this in the Y direction. So we would have the normal, and let's go back. The leftward forces would equal the right forces if they were not accelerating, and the sum of the upward and downward would equal gravity. So eventually we would get to this point to be able to say this statement. Force due to gravity would be equal to force normal plus the Y component of tension. So let's try another one. So please try 3, 4, and eventually the remaining ones. But let's walk through number 5. So we have the squirrel, because that's our object of focus, sitting on a roof. If you notice, the roof is tilted. So there's going to be a special condition for any surfaces that are tilted. So we have definitely gravity going down and our normal force going up and to the left. And what's preventing our squirrel from sliding off the roof? That's friction, which is at a right angle. And if we follow the rules from before, we would break up normal and friction into X and Y. And that would show all the upward would equal the downward, leftward would equal rightward. But that doesn't quite make sense, because where does the squirrel actually want to go? Or where is he potentially going to slide? Down to the left. So we need to make that make sense. So for any case where our surface is tilted, we are either going to tilt our paper or redefine our x and y directions. So if you will, if this is our y coordinate, or this is y-axis, this is our x-axis, it's just like what we've done before. So we're going to break up, in this case, gravity into its y component and x component. So now we could go ahead and make some statements. He's definitely not moving. So in our redefined x and y, our normal force would equal to the y component of gravity, and the friction going up the roof would be equal to the x component of gravity. So that would be a proof, kind of like what you used to do in geometry, to show that the object, for physics, to show that our object is or is not accelerating. So do me a favor and go ahead and try the rest of worksheet 1B and check your answers with the solutions. Please be sure to note any questions, problems, or concerns so we can address them the next class. Thank you.